Okay, now that we have learned how to rotate a series of faces, I'm going to work with a box and start rotating them based on a graph mapper. So what we will have here is, as you can see here, a graph mapper, which is going to change the form of the strips. So we're going to talk how this is going to affect the rotation. We're also going to define the location of the rotation with two parameters. One is the location of the column we want to rotate. So for example, you can see that I can change the location. If I give it 4 sliders, it's going to be 4 columns. And another slider is going to control the center for the graph mapper. So you can see if I change that, this is going to rotate and move the graph mapper up and down. So we can control, and we're going to talk how we can divide the strips into 2 parts. One is those who are going to rotate, and another one is going to be those who are not going to rotate. Okay, to first show you how the algorithm works, I'm going to turn it off and zoom in here. The first part is the unit you have. So for example, if we make a box in Rhino, you can simply go to box and draw a box here and give it to this brep. So I can right click and set one brep, and this is going to be the units we're going to use. I'm going to go back to the small brick-like one because it's going to give us better results, and right click and internalize it. So we have it here. Let me put the bifocals here. For the box array, we can go to transform and use this box array to make a box, an array in the XYZ direction. For the X, it's going to, as you can see here, this is going to change the number of columns we have in the X direction from the same box. This is going to be Okay, to work with the box array, I'm going to go to full names and explain what's happening here. The first one is the geometry, which is going to be the unit we have here. I'm going to give that to the input here. For the cell, you have to give a bounding box. So if you give this same box to here, it's going to use that, but you can also use the surface bounding box. Get the bounding box from the module you have and then give that to the cell. It's going to give you the same results. The number of X we have here, you can control that. The number of Z, and for the Y it's going to be 1, because if I give it like 2, you can see it's going to go backwards. So we don't need that. We just want a complete brick-like part for the box array. To define the location of the point attractors, let me increase that here. So we have more of these here, okay, and more of them in the X direction. What we need here is to use an evaluate box. So evaluate box is a tool, you can find it in Surface Analyzers evaluate box. We have to find the union box. You just give that to the box array and right click and use a union box. It's going to find a complete bounding box from the form we have here, as you can see here. Why are we using this? Because we want to define the point attractors inside that box. So you give that to the evaluate box. The UVW parameter is the, if we have a box like this, this is going to be, for example, U, this is going to be V, and this is going to be W. So it's usually between 0 and 1, so you just have to give number sliders between that. For the V parameter, I'm going to give this a 0.5 because we just want this to be exactly at the center, and use this point to compare it with the centroid for each box. So we're going to use that to 0.5. For the U parameter, it's going to change the location in the U. That is going to indicate which columns we're going to use, and we can change that here. You can increase the decimals if you want to, and for the W, it's going to go upwards and downwards. So this is going to be the location of the graph mapper. So if we have a sine wave, it's going to start from here. That's also important. And now we have the point, and we can use that for the rotation.